Good morning, everybody. Sorry for the late start. We will catch up today at the end of this lecture. Yesterday, we looked at the slicing problem, what is the definition of the slicing problem, why it is happening, and then instead of assigning objects to objects, we tried using pointers of base class and the pointers of the derived classes, and we came up with this solution. We said that in this case there is no slicing problem, but doing this illegal. I cannot access the breed field of the pet using this notation. So it is kind of expected. This is no problem, but I mean, maybe we shouldn't call the slicing problem a problem. Okay, it's a language design issue. Okay, it is designed this way and it is right, and don't call it a problem, but we say it the slicing. Okay, that's slicing procedure. If you do this kind of if you do this kind of assignment, if you have two objects of pet and dog, and if you make this kind of assignment, slicing will happen. Let's not call this a problem, but slicing let's call this procedure slicing effect. Okay, so slicing will happen, and you should know about this. You should be aware of this. And then they said that instead of using the objects of these classes, let's use the pointers of these two classes. And in that case, slicing doesn't happen. Okay, here's what I did. Okay, I have two pointers, pet pointer and a dog pointer, and I make a new dog, and I give a new name, and it changes the breed, and then I do this assignment. Since there is an is-a relationship between these two classes, I can do this assignment no problem. The other way around, okay, assigning a P pet to P dog, okay, is not allowed because there is no is-a relationship between those two. Okay, remember, is-a relationship direction is this way: all the cats are pets, all the dogs are pets, but not all pets are dogs, or not all pets are cats, right? So is-a relationship is the direction of the arrow of the inheritance in the UML diagrams. Okay, so and last time I think I was going to show you the code from the book. Where is the code? Yeah, here is the code. And okay, pet, very simple class. In fact, we don't like these kind of classes because it makes everything public. Okay, for the sake of simplicity, we prefer that way for this example. And then a dog derives from pet, and I have one more data member, breed, and I am overriding this print virtual function. And let's look at those two functions. Print for the pet, it prints the name of the pet, and for the dog, it prints the name of the pet and the breed of the dog. Okay, so this is what's happening. Okay, and we looked at this example. I have two objects of the dog and pet. I give them names, Tiny, Great Dane, and I made this assignment is a relationship. And when I say v pet.print, all I will get is the Tiny, right? So this will print only the name of the pet, because the v pet doesn't have any data members to carry this breed. Okay, so v pet.print, line 32 question. Print is a virtual function, right? Line 32, print is a virtual function. Is line 32 a late binding, or dynamic binding, or static binding? Is it an early binding function or a late binding function? Remember, print is a virtual function.
vpet is not reference or pointer, so it is a early binding.
Exactly. vpat is not a reference or a pointer, okay? Since I am calling this print function, even though it's a virtual function, since I am calling this function directly on an object, it is definitely an early binding, okay? So vpat.print will call what? This function, okay? And this function has only access to the name data member of the pet, of course, because pet doesn't know about the breed. And let's do the other thing. I have 2 pointers, and I assigned a new dog to a p dog, which can happen, right? No problem. And then I assigned these 2 data members, Tiny and Great Dane, and I assigned again, like I am doing here, right? Like 29. I am assigning p dog to p pet, and then I have 2 things, okay? I am printing ppet.print and ppet arrow print and pdog arrow print, okay? So what's going to happen? Line 43. Tell me what happens with line 43. Which print will be called? Dog print or pet print?
Dog print, sir.
It's a dog print. Muhammad, why? Why is the dog print?
Because we assigned it before call it.
Because I know that ppet, right? ppet
Return object, dog object.
yeah, ppet is pointing to a dog object, and during the runtime, what does the compiler going to do? Let me show you the other thing again. It will follow this procedure. It will take the pointer, it will find the object, okay, and it will figure out that this object is a dog object. It will go to the dog object's v table, and it will find the print function in that table, and it will run it, right? So that will be okay. How about this one? Line 44. Line 44 will call what?
It is also using dog
Print function. Exactly. It is also using the dog print function, because the same thing again. I mean, these 2 pointers are pointing to the same object. Okay, since print is a virtual function, it will be decided during the runtime. Okay, so that means that using the ppet, which is a pet pointer, I could print out the breed data member of the object itself, okay? But how about this? If I do line, okay, if I do line 48 and 49, let me do it clearer. Okay, let me do this. Okay, okay, good. Oh no, let's make it syntactically correct. Good, and put a column there. Good, okay. How about now? Is line 48 going to work? Line 48.
Yes.
Yes, it will. Why? Because ppet is a pet pointer, and there is a name data member in it, and it will work. How about 49?
No.
No, of course no. Okay, so good. Why not? Because in the pet class, ppet is a pet pointer. In the pet class, there is no data member named breed. Okay, but there is a function member named print. So calling print on pet is okay, but trying to access this breed data member is not okay. By the way, sometimes some creative students, they come up with this idea, why don't we make a data member virtual? That way I am overriding a data member when I drive a new class and etc. No, this is not possible. Okay, this is a bad idea. Okay, C++ doesn't allow it, and that's a bad idea because we don't want to access our data members like this anyway. And if you are doing polymorphism has to be done. Polymorphism has to be done using the functions. Or some people, I mean, I think nobody asked me this in this class, but usually they ask it. I think it is the effect of online classes maybe. They say that I like to in the Drive class, I like to redefine this name. Okay, I am going to make it integer. Okay, don't do this. This is not something good. Okay, so it is like you are redefining a data member. In inheritance, there is no redefinition of data members. In inheritance, there is no overriding of data members. Okay, overriding and redefinition and overloading is only valid for functions. Okay, I'm going to show you some. Okay, if I add this line, okay, p dog is p pet. Let's look at this line 43 and 44. Line 43, we already did it. There is an is a relationship. Line 44 is illegal. Doesn't this sound funny? It's like I have two integers, I and j. I am assigning j to I and then I to j. Why can't I do that? Because I know that ppet here, ppet points to a dog object, right? Ppet points to a dog object. Why can't I make this pointer assignment? The compiler will tell you no.
Compiler doesn't know we assigned before.
Yes, compiler is not that smart to figure out that, okay, this got to be it or no. Compiler is not supposed to be that kind of smart, okay? I mean, compiler says that, okay, I compile it by line. I don't have to make any logical decisions for you, okay? This is not simply valid. This is not there is no is-a relationship here. I mean, if you are going to make an assignment, assign it using the direction of the UML diagram arrows, okay? You could assign dog objects or dog pointers to pet pointers, but the other way is not allowed. So, but here I know that this pointer, if the assignment is allowed, is going to work. I know that, right? I know that thing is going to be assigned fine, and I will be fine. I am not trying to. Okay, but okay. This would have been. Let me try to write this here again. Let's say I have a cat object. Remember my hierarchy here? Pet, dog, and cat. This is cat. Okay. And let's say I have a cat object. Okay, and I assign that cat object pointer to pet pointer, which is fine. Then line 47 would be very, very troublesome. Right? So while line 47 should never be allowed, and you would say, and the compiler is right in this case. But I know that line 44, if the compiler allows it, is going to be fine. So we are saying that there should be one way of achieving this. I am sure do this assignment. I mean, in C, this would have been easier, because in C, if you are sure, you can do anything you like convert it to a void pointer, typecast it, and you are going to be fine. For example, like this, static cast. Okay, like, and I am going to do this dog pointer. Okay, so C++ doesn't allow this either. I mean, if I am trying to force this compiler that you are going to make this a dog pointer, compiler says that no, I am not going to do that. In C, maybe we can convert it to a void pointer, and after the void pointer, we can do anything that we like. But in C++ is not like that. Instead, we have this. Okay, this is an error. Instead, we have something like this. Okay. Instead of static cast, there is this dynamic cast. Dynamic cast, as the name implies, remember at the beginning of the semester, you asked me if there is a static cast, what else do we have? We have dynamic cast, okay? Dynamic cast does this. Okay, this is not error anymore. If the assignment is doable, that is, okay, if this path is pointing to an object that pdog can point to, let's say like a dog object, then this assignment is going to be okay. It will do the assignment. Otherwise, it will assign a null pointer to pdog. Okay, so this will correct pointer or null pointer. That's what dynamic cast does. Okay, that's what dynamic cast does. So this is always okay. This is called upcasting. Upcasting is I am making this assignment upwards. Okay, I am assigning a dog object to a pet object or dog pointer to a pet pointer. Upcasting is always okay, but downcasting, that is trying to assign a pet pointer to a dog pointer, is dangerous, and you need to be careful about it. And this is how you are being careful. Okay, this is error. Why? Because this is downcasting, uncontrolled. Okay, uncontrolled downcasting. Okay, this one is again downcasting, but this is controlled downcasting. Of course, right after doing this, let me use a different dog pointer name here. pdog2. Okay, I did this, and of course after doing this I should start saying if pdog2 is not a null pointer, then I can maybe do this. Okay, I can cout pdog2 read. Okay, without using this f you'll be in trouble, because sometimes pdog2 is going to be a null pointer. In that case, doing line 47 on a null pointer is going to give you a segmentation fault. Okay, so I introduce you to new things now, upcasting and downcasting. We have been doing upcasting all the time because upcasting is something allowed with C++ all the time. This one is okay. Line 43 was always okay. This one is okay too. if you like. Okay, more explicit. I am converting a dog pointer to a pet pointer. It is upcasting. It is okay. Okay. Good. Any question on the downcasting and upcasting? We have been
Sir,
sure.
can we overload assignment operator and making this pointer pet, comma pointer dog? I didn't ask correct, but my question is, why do we need line 47 actually?
Why do we need line 47? Well, I know that. Okay, let me give you an example. That's a good question. Okay. Well, yeah, okay. So you are saying that why do we need downcasting anyway? You are saying, right? Is that what you are saying? Maybe that question is the same as maybe why do we need upcasting? Okay. I mean, why would we need assignment of pointers in a hierarchy? Okay, downcasting or upcasting. Okay, but we did upcasting a lot. Let's go to our example here. Remember the example that I showed you before? This one. Okay. Here, remember there was a loop. There was a global function. Okay. Virtual via pointer. This virtual via pointer or virtual via reference, to be able to call such a function, remember what did we say about these two functions? These are very generic functions. Why? Even though I write these functions only knowing the employee class without knowing anything else, okay? These two functions knows only about the employee. They don't know anything about the hourly employee, salaried employee, commission employee, etc. Right? That's why we say that these are very generic functions. They could be used. Okay, but how am I going to call these functions? I am going to call these functions using employee pointers or employee references, but employee is an abstract class. I cannot make any objects of employee. So what am I going to do? Of course, I am going to call them using upcasting, right? How am I going to do that? I am going to call, okay, there is an employee pointer vector, and each one is a employee pointer here. And I will, when I call this virtual via pointer and virtual via reference with the employee pointers, okay, with the employee pointers, I am doing an upcasting, right? So your question, was that Mohammed? Mohammed, was this your question? I think Mohammed asked the question. Mustafa asked this question. Okay. So Mustafa, the need for upcasting is obvious, right? I mean, we know why we are using upcasting. So your question is kind of, maybe I change your question a little bit, but after I explain this, I think your question will be clearer. But then why do we need downcasting? Okay, upcasting is writing for generic code. To be able to write generic code, I need upcasting. Okay, to be able to call this virtual via pointer, okay, it's going to be all upcasting, okay, because actually the upcasting is happening here, not there, but here. I am assigning the salaried employee to employee 0, this, there, and there, right? Or I could have done this. I could have directly call virtual via pointer and directly employees 0. So when I'm calling this function, I am doing upcasting. Upcasting is required to write generic functions. This slide set has another example of the employee hierarchy that uses downcasting, and let's see how it does that. Okay. So it says that I have my payroll system, bordro sistemi. I have a number of employees. Okay, I am using polymorphism again. But now I am going to give 10% raise to base plus commission employees. Only to them, right? I am going to write a function that will take all of my employees or any kind of employee. So I am going to get a vector of employee pointers. Okay. But I will give only 10% increase to the base plus commission employees. This is how I'm going to do that using the dynamic casting operator. Okay. So I included all of my headers, 5 of them. My main function. Okay, I have an employee vector here. Salary the employee. Okay, I'm doing my upcasting. These are all fine. Okay. Here is my loop. Between line 44 and line 63. Okay. I'm saying that line. Okay, let's look at line 46. Line 46 is a generic line. It calls the print function of the base class employee using a pointer. And I know that print is a virtual function. So that's it. It's going to be a late binding. So this is a very typical example of polymorphism, line 46. Because I don't know the meaning of print. It changes from run to run, from loop iteration to loop iteration. At iteration 0, when I is 0, print has a different meaning. Okay, when I is 1, print has a different meaning. That's the exact meaning of polymorphism. Many faces, many forms, many shapes. Print is taking many shapes. That's fine. So this is a classical example for polymorphism. Okay, but in this case, I like to be a little bit specific. Why? Because I want this loop that will end where I think it will end at line 66. Can you guys see these letters? Because I cannot I don't know how you are saying it. Are these letters visible? Should I make it a little bit larger? You guys are seeing it, right?
Yes.
Okay. Out of 70 people, I get a yes after 30 seconds. Good, okay. So Mustafa sees it. I guess the rest of the class sees it too. This loop that ends at 66, okay, it's a generic loop, but I like to be specific for some cases. I am saying that if my current employee, that is employee I, is a base plus commission employee, then I will give him or her a 10% raise. %10 zam yapacağım. Okay, so this is what I do. I take employee I dynamic cast it. I take employee I dynamic cast it to base plus commission employee pointer. Employee I is a employee pointer. Base plus commission employee, okay, is derived from commission employee, and commission employee is derived from base class employee. So if the pointer is pointing to the correct object, that is, if this employee is pointing to a base plus commission employee object, this derived pointer is going to be not null. Okay, is going to be not null. So line 50 makes that, okay, line 51 makes this decision dynamic cast. It is going to either assign a 0 null pointer, or it's going to assign a right pointer which will point to a base plus commission employee. Okay, so that's why I check line 56 if the right pointer is a null. Okay, let's correct this. It's going to be null PTR, because we don't like to use 0 in place of nulls anymore in C++. These slides are very old. Okay, It is not using C++ 11 standard. It is using C++ 98 standard. Okay, if the right pointer is not null, that means that this assignment has happened. Then I will do this. I will get base salary. See, this get base salary will work. Why? Because the right pointer is pointing to a base plus commission employee, and it has get base salary. I will get the base salary, and I will multiply it with 101.10. Okay, and I set the base salary, and then I am just making sure that I did it right. Okay, after the if ends, I just print out the earnings of the employee I, just to see, because remember prints the earnings too, and this one will print the earnings, so I will see if the earnings has changed. Okay, so this part of the code, okay, the part that I am going to mark with green is a specific code. This part of the loop is not generic. It works only for, it is written only for base plus commission employee objects. But the part that I am marking with red, two parts, is generic, because those lines use only the interface of the employee class. Mustafa, did I answer your question?
Yes, sir.
So I mean, that's one of the tricks of being an instructor. You answer your questions without understanding what the question is. I did not know what your question is, but I knew that this would answer your question. So upcasting we like a lot. Upcasting is writing polymorphic programs, okay? Upcasting we like a lot. Downcasting we use it for writing specific code. And writing specific code would work only for certain classes. So we don't like the downcasting a lot. But sometimes we have to do it. Okay? Sometimes we have to behave specifically. Did I give you an example about operating system doing? Okay. I think at the beginning of this, maybe here. Yeah. Remember this Windows application? I said that there is a Windows application base class, which is an abstract class, by the way. Okay, you cannot make objects of this Windows application. So if you are writing a new application, you have to derive your application from the Win app. Okay, and okay, let me make all of them. Let me make all of these. For example, what did I say? If you are writing a Windows application, you have to provide me a close function, a resize function, a minimize function. Okay, these are all pure virtual. Okay, these are all pure virtual. And if you don't write your pure virtual function for a calculator, then you cannot, your calculator becomes an abstract class too. Okay, so you cannot make a objects of calculator. Your calculator application will not work. Okay, so remember this close all function, static function. It takes a Windows application pointers, and it closes all the applications of an operating system. Before you shut down your computer, right? Before you shut down your computer, okay, you close all of your applications, and this is a generic code. This will work for any kind of application. And this was written like 20 or 30 years ago, but it works for all kinds of applications, because if you have an application, you have to override this close one. So here maybe I can say something like this. I can say something like this. Close all the applications other than the calculator applications. Okay, so what would I do? I would say if dynamic cast calculator pointer and app. Okay, I am doing the dynamic casting of this pointer app. Okay, like exactly I did it with the employee. Let me go back to that one and show you that these are very similar. This is what I am doing. Okay, here I was dynamic casting an employee pointer to a base plus commission employee pointer. Now I am doing a win app pointer, converting a win app pointer to a calculator pointer. If this one is not null, that means that it's a calculator pointer, right? So what is my purpose here? I am going to close all the applications other than calculators. So if dynamic has calculator pointer app is not, or just opposite, is null pointer, then close it. Okay, so this close all function closes all the applications other than the calculator. So this part of this green part here of the code is not generic because it knows about the calculator. Previously, I didn't know anything about the calculators. If you like to write this kind of generic code, then you are going to use downcasting. And with the downcasting, you need to be careful. Why? Because downcasting directly, if you are done, it is illegal. Okay. Like this one, it is illegal. Downcasting is illegal. But if you are doing it through the pointers, and if you are doing with the dynamic cast, then you should be fine. Okay, this is what the book says about downcasting. If I have two objects, converting to a pet to a dog is illegal. Downcasting is illegal. Upcasting is always legal. Doesn't matter if you are doing this or that. Okay. This is casting automatically. This is casting explicitly. Upcasting is always okay. Downcasting, again. Downcasting, I have a pet pointer. Okay, and I'm using this pet pointer to point to a dog. If you do it, then yes, you will get the right pointer if the object is right. It says that rarely done due to pitfalls. I don't agree with this a lot. Okay, and sometimes sometimes I need it. And understanding downcasting is understanding upcasting, actually. Understanding what hierarchy means, understanding what inheritance is. That's why understand downcasting. It is important. Okay, good. Okay, we talked about the inner workings of the virtual functions, and I think that's it. One more important thing about the inheritance. This is important. Okay, virtual destructors. Remember our hierarchy, simple hierarchy of PFRAD and PFRAD backup. Do you remember that? Should I? Okay. Let me. Chapter 14, right? Let me open that again. Chapter 14. I think it was here. Okay. Loading the headers should be enough. Okay. So pfRAD contains this pointer, double pointer, and pfRAD backup contains this double pointer too. So that's why, since both of them has these pointer stuff, both of them have their own big three, including the destructor. Here I like to do this. I'm going to use upcasting again. pf array backup, or maybe I should do this. Okay, pf array pointer pp. Okay, pf pointer, and I am going to assign a pf array backup 10. I'm using upcasting. This is a backup object. This is a pfRAD object. Since upcasting is okay, I can use it freely, no problem. Upcasting is okay. I did stuff like, no problem, I should say maybe pp add element. Whose add element is this? pfRAD add element or pfRAD backup element add element?
Backup.
No, try it again.
pfRAD.
We did not override, or we did not redefine add element. Remember, add element work exactly the same. pfRAD backup did not change any behaviors of pfRAD. It only added new stuff, right? For taking a restore and backup, right? That's what it did. So even if it did, when I do this, since add element is not a virtual function, remember in chapter number 14, we did not see any virtual functions. Even if it did, okay, add element is going to be the add element function of the pfRAD, right? Because there is no virtual in there. But anyway, I mean, we did not redefine any functions of the base class in this hierarchy other than the constructors. Okay, and the making a constructor a virtual doesn't make any sense. Okay, maybe I should ask you this: why doesn't make it any sense to define a constructor virtual? I said that, right? I said that it doesn't make any sense to define the constructors virtual. Why? Why doesn't it make any sense?
If it is pure virtual, we cannot create object, so we don't need the constructor or the constructor.
So for the pure virtuals, yeah, but I'm just doing a regular virtual constructor. How are you gonna call a constructor using the base class pointer, right? You cannot. Constructors are automatically called when you make objects, so it doesn't make much sense. So for the constructor, there is no being virtual. But when I do this add element thing, and then I would maybe print out pp get used, right? I can do that too. When I am done, I am going to delete this pp, right? So whose destructor is this when I delete pp? Whose destructor is this?
Backup.
Riot class, I guess.
You wish that because you wish that it is the backup classes destructor, because if it is not the backup classes destructor, you are in trouble, right? That's what you think, right? But how does the compiler know that it should call the backup classes destructor? This is a PP, which is a pointer of pfRAD, right? How does the compiler know that it should call the derived classes destructor? We didn't say anything about it, because destructor is not virtual. So the idea is, let's declare the base class destructor virtual, like this. Let's go there, and pfRADH, let's make this virtual. That will automatically make this pfRAD backup destructor virtual, but I am writing it anyway. So if somebody makes a deletion, a dynamic memory deletion like this, it will follow the pointer, it will find the object, and it will call its destructor, backup destructor. Okay? If you don't declare your destructors virtual in a hierarchy, then you will be in trouble with this kind of usage. So it is very important to declare your destructors of the base classes virtual. So make it a habit of yours to declare your base class destructors virtual. Even if you don't need the base class destructor, just declare an empty destructor and make it virtual. Okay? So that if somebody derives from your base class, and if he or she uses dynamic memory allocation stuff and they have their own destructors, in case you delete those kind of objects using the base class pointers, right destructors will be called. Okay? You understand the need for the virtual destructors? It is for, you have a derived object, you are keeping a base pointer to it. When you delete the base pointer, the compiler has to have a way of knowing that it is working in a hierarchy. If you do this like that without declaring the virtual destructor, this destructor will be decided during the compile time. But I like this deletion to be decided during the runtime. So make destructor virtual. Good policy for all destructors to be virtual. Because you cannot say, you don't say, I will make that decision later if in my hierarchy, if somebody uses the dynamic memory, etc. No, because when you are writing a class A, you don't know if your customer is going to derive from your class A, customer A. You don't know that, right? You are free to write a class like this. Class my string public string. Remember the C++ standard string class? You could derive from it and make it my string, and you do whatever you want. Okay? So whoever wrote that string did not know that you are going to derive from it. So it is better for this class to have a virtual destructor. Okay? Good. Any questions? Any questions? Okay, if there are no questions, let's take 10 minutes of break. After the break, we will continue. Let's be here around 11:40. 11:41. Okay, we are done with chapter number 15, polymorphism. So that completes our discussion of the 4 main fundamentals of object-oriented programming. That doesn't mean that you have learned everything about the object-oriented programming languages. There are many other details, and there are very sophisticated techniques that uses all of these ideas together, and we usually call them design patterns. Okay, design patterns. With the design patterns, what you do is you follow a number of rules, a number of, let's say, procedures to come up with program architecture, software architecture, and usually these patterns follow object-oriented programming rules. They say that, for example, try to prefer composition instead of inheritance, okay? Or there are some rules, okay? Code against the interface. Okay, so you should write your code always using the interface. What do I mean? Just look at the interface of your header files. Okay, pick the most generic one and write your code. Remember our hierarchy, employee hierarchy. Let me show you this again. Let me show you. Where is my... Okay, here it is. Let me go to the employee class, if I can find it. Where is the employee? Yeah, here it is. Okay. Employee class is the most generic class of all. if you write your code using only this employee class interface, using this set name, get name, etc., or these virtual functions, you cannot get any more generic than that. Okay, so one of the object-oriented programming rules or the design pattern says that write your code as generic as possible and use only the interfaces. And remember the Java collections hierarchy. Let me show you the Java collections hierarchy again. Okay, one here. You're not seeing it yet, I know. Okay, here it is. Okay, if you are writing your software, developing your software, okay, try to use classes that have a position as high as possible in the hierarchy. If you can write your functions, your new software module, using only iterable objects, using only the collection, using only the queue, you are fine, okay? If you start using classes that are way below, like these, then you are not writing generic code, okay? You are writing specific code. To be able to write reusable, more generic code, then use these, okay? And if it is possible, use this one. You might say that let's look at the definition of iterable, and you are gonna see that it doesn't have much. Sometimes it is not enough. I mean, that sometimes it's not powerful enough to write whatever you want. Well, in that case, you are gonna go here, there, or there, okay? So, but always try to write your code against the interfaces, which are the higher objects in the hierarchy. Okay, so there are many things like that. Object-oriented programming, object-oriented design rules, and you're gonna learn them in your software engineering class and object-oriented software engineering classes in your 3rd and the 4th years in this department. Okay, so I only introduced to you only the 4 main fundamentals of the object-oriented programming, and we are not talking a lot about the software engineering aspects of it. We are mostly interested in how we can do that kind of stuff using C++ and Java in a short while. Okay, so when I say I introduced 4 main fundamentals of the object-oriented programming, basically abstraction, encapsulation, inheritance, and polymorphism, that doesn't mean that you know everything. Everything that is to know about the object-oriented programming. Not yet, but you have a very good foundation now. You can understand what people say about those kind of rules. Okay, but whatever you do, we are trying to write reusable code. We are trying to write easy to maintain code. We are trying to write easy to debug code. Okay, that's what we are trying to do. Okay, one technique that people use a lot to achieve some kind of abstraction is templates. Sometimes they say that, okay, this is the abstraction of algorithms, templates, and we are going to use this a lot with C++, and in Java they use it under the name of generics. As the name implies, it's writing generic code again, okay? And this is important. We use this a lot, and in fact we have been using these templates in the form of vectors. Vectors are examples of templates, actually. Okay, now we are gonna see how we are gonna write our vector type classes, and you are gonna see that it's going to be very, very useful thing. Okay, so let's get started. Let me clear out my annotations from previous lectures. I will give you an example first. The example is this. Where is the example? Okay. Let's say I have a function like this. Swap values. Very, very easy, simple function. It just... What happened? Annotations. Clear all of my annotations and clear all. I hope it cleared it. So it takes two integer references and it swaps their values. Sometimes we use this. It's a very useful function. Especially we use these kind of functions for sorting, right? Remember the bubble sort? It keeps swapping elements if they are in the right order or not, right? Bubble sort or sinking sort, same thing. It keeps swapping stuff. If one of them is not in the right order, we just swap them. That's what we do. So this is going to be very useful for swapping two integers. But swapping two integers is not the only swapping related thing that we do. Okay, we may say that let's write another function to swap characters. Well, this is good for sorting character arrays, right? Okay, this is character arrays. How about swapping doubles? How about swapping many objects? Okay, how about swapping vectors? So I have to write almost the same code for different types, which is called repetition. They are doing the same algorithm. I have a temporary data, either it's character, integer, double, or vector. I assign this variable 1 to that temporary var2. So the assignment is, so the algorithm is same, exactly the same, only the data types changes. And we don't like this. Why? Because this is copying and pasting. And you might say that this is a very simple function. What is so big about, what is so wrong about copying and pasting and modifying this kind of function? Well, yeah, maybe this is manageable for 4 lines of code of swap values. But if the functions get larger, like maybe 20 lines, 40 lines, and if the number of functions get larger, 5, 6 functions, I am going to do the same thing. That's not going to be manageable. And if I find a simple bug in one of the functions, then I have to fix lots of other places because I made lots of copies. So we don't like this. We don't let this go. We have to do something about it. So templates, function templates, okay. Instead of overloading this swap values, we are going to use function templates, and the compiler is going to do this overloading for us automatically. Okay. Instead of me writing many functions, I am going to write one simple template function, and the compiler is going to make copies and modifications for me. That's what it's going to do. Okay. Template in Turkish is going to be şablon. Okay. Well, şablon is not Turkish. I think it is French, but that's what we say, şablon. So you know those kind of rules that we use in our primary school, right? Şablon cetvel. Yeah, okay, like this one. So this is a template. This is okay, I like this one because it has the Turkish flag and Atatürk, right? Okay. Where did it go? Come back. I don't like this template because it is... Okay, this is good. Okay, that's a template of different size circles. Okay. Using this template, I can make I can make any circle that I like with different colors. I can use pen or pencil. I can fill them in. Okay, I can do many customization, but circle stays the circle. And I am going to do the same thing with my functions. So I will define a function in generic terms, and I will let the compiler make copies of it and instantiate it for me. So this is what we are going to do. Here's a template. Here is your first template in your life. Function template. Template is a C++ keyword. In fact, let me show you the real code. Template is a C++ keyword. It's a new keyword. Okay. And it says that I am a template, I am a function template. So this function here is not by itself useful, but it's just a template, it's schablon. Okay. This template uses class T. There is no class T defined in C++, and we are not going to define any class T's, okay? It's a generic class. After giving this template header, this is called template header, that tells all the compiler that you are starting a new function template. Now, this is the name of my function template, swap values. Okay, the swap values function will take two variables of type T reference. Okay, and this is my function itself. I have a temporary variable of type T. I will assign variable 1 to temp, variable 2 to variable 1, temp to variable 2. Okay, that's it. So I am done with defining this template. Now I have my template ready. So how am I gonna use this template? This is very easy. This is what you do. I have two integers, integer 1 and integer 2. I just call this function like there is a swap function, okay, with two integers. When the compiler compiles this program, I am not talking about runtime, I am talking about compilation time. Okay, when the compiler compiles this program, when it sees it, it says that, is there any function named swap values? It finds it, no, there is no function named swap values. Is there a template definition for a function named swap values? Yes. Okay, so if I make this T an integer, can I instantiate this template? The answer is yes. Okay. If I instantiate this template by replacing all those T's with an integer, okay, by replacing all those T's with an integer, with an int, then this function is callable. So the compiler automatically, as soon as it reads this line 23, the compiler automatically will write a function that will take two integer references, and it will replace all of those T's with ints, okay, and it will call that function, and it will produce code to call that function, swap values with integer. So this happens during the compilation, not in runtime. In runtime, there is a function that takes two integer references and it just calls it. Okay, so it happened during the runtime. So we are done with calling this swap values with two integer references. I continue, okay, so the original integer 1 and integer 2 is going to be 1 and 2, but after the function is called, when I run this program, integer 1 and integer 2 will have swap values. Now I have two characters, A and B, okay, symbol 1 and symbol 2. I am calling the swap values function. The compiler says that, are there any functions that takes two character references? The answer is no. Is there any templates? Are there any templates that I can instantiate with a character reference so that I can make this function call? The answer is yes, yeah. You could instantiate this swap values template with character references, and this is going to work. So at the end of this main function compilation, you will have one main function compiled, one swap values function with 2 integer references as parameter compiled, and another swap values function that takes 2 character references compiled. Total of 3 functions compiled. When you run your program will run like a regular program. So template instantiations and template things happen only during the compilation time, not runtime. Okay, so basically what the compiler is doing is behaving like a monkey. Okay, it's doing something very, very easy. When it sees this line 23, it immediately does this. It just copies this. Okay, copy this. I copied it. Now I am going to do this Control H thing. So I will replace all of these with integers. Okay. All of the t's with the integers, and I will do this only between line 18 and 25. How can I do that? Is there any way to do that, people? Anybody knows that? Seçildiğinde? What is, yeah, okay, good. Maybe I can do that, okay. Sonrakini bul. Where is sonrakini bul? Where is it? Yeah, not that one, not that one, not that one. Okay, now replace it, replace it, replace it. Now I am done. So I have a new function named swap values that takes 2 integer references. Okay, now I am done. When I see this line though, swap values with 2 characters, and the compiler is doing the same thing again. Paste this, okay, and again Control H, replace all of these with the characters. Okay, I'm going to do the sonrakini bul thing. I am going to go there. Okay, now I can change this now, right? Change it, and change it. So I have changed all 3 of them. I am done with that too. Okay, that's it. So that's what the compiler does actually. So instead of me doing the copying and then pasting and modification, compiler is doing that automatically. Of course, it is not modifying your code. Okay, it is not modifying your code at all. Okay, and it is doing this under the hood. And every time you make a compilation, compiler does that automatically. So this is what we call templates. Okay, that's the main idea of function templates. That's the main idea of function templates. Any questions?
Sir, can you use auto in here?
Where would you like to use auto? I mean, you mean here? Here?
Yes.
Well, if you say auto, how would the compiler know the type of temp? If you say like, okay, this would work, yeah. Yeah, if you say it, yeah, it will work. And erase this line. So the compiler is going to say that, okay, the type of temp is auto. It is the same as variable 1, and variable 1 is t. When you replace t with an integer, so temp will be automatically integer. Yeah. Good. Any other questions?
What if we will send a send function to different variables?
2 different variable types.
Yes.
Is that what you are saying? So you are saying that I am sending a character and an integer, right? Like this, right? Like that? Line 29?
Yes.
1 character, 1 integer. In that case, compiler is going to ask this question. Is there any function that takes 1 character reference and 1 integer reference? The answer is no. Can I instantiate a template, okay, with two different types, one character reference and one integer reference. If I replace this t with character, it will replace that one too, right? That will not work. If I replace this one with integer, and that will replace that t too, so that will not work. So in this case, your line number 29 will not work. Line number 29 will not work because I cannot instantiate it unless you have a template definition like this. Okay. I have one variable, reference of type t, another reference of type k. Okay. In that case, this is instantiatable, and variable one type will be t. In this case, it's going to be what? A character. Okay, character. It's going to be character. But then this is going to be a problem. Why? Because I need to assign an integer to a character to a integer. So if these two assignments can be done, then you will be okay. Otherwise, it will be a problem. But I mean, the main idea of your question is, can I have a template with two different generic types? The answer is yes. You could have 1, 2, 3, 4, 5, 6, whatever you want.
Can I ask a question, sir?
Sure.
Can t and k both be integers or characters?
Yeah, this will work. This will work. I mean, your program is compilable like this. They don't have to be different.
Okay.
Okay.
Thank you.
They don't have to be different. T and k will be exactly the same, as long as these assignments is doable. Then you are going to be okay. Maybe it's going to work with the character and the integers, but this is not going to work with character and strings, right? If one of them is a string, the other one is a character, then it's not going to work. Okay, good. Are people asking question? Nejat has a question. Can we do this with use void pointer? Well, that's a very deep question, Nejat. I don't know what you're asking. Can we do what? Can we do templates? Why not? I mean, if you like to swap the values of two pointers, if this is what you are asking, okay. Void pointer p1 and void pointer p2. p1 is the address of let's say integer 1, and p2 is address of integer 2. And what you want to do is swap values p1 and p2. Yeah, it will work. Exactly. Also, swap values p1 and p2. That will work too. Okay, so this is going to instantiate, this is going to replace all those t's with void pointers. Okay, oh no, this one is not going to work because dereferencing a void pointer is a bad thing, right? Dereferencing a void pointer is a bad thing, so this is not going to work. But void pointers, I mean, if this is what you're asking, yeah. But better thing here is maybe if I do that, both of them will work. Okay, the line 36 is going to instantiate p1 and is going to instantiate that template with a integer pointer. Okay, so I am swapping to the values of those two integer pointers, but line 37 swaps the integers, not the pointers. Okay, so in fact, line 37 and line 22 are using exactly the same function. So line 22 is going to instantiate one function with integer reference. 29 is going to do it with a character reference. 39 is going to do it with the integer pointer reference. 37 is going to do with the integer reference, but integer reference is already written and compiled, so 37 is not going to instantiate anything. This is already here. We already have this. We already have this. Do that kind of experiment, okay, and compile this code using -e flag. Remember -e? Sorry, -s flag, capital S, which produces the assembly for this code. And go to the code and see how many swap values functions are there. And you will see the produce code, okay? You will see the produce code. Okay, so Anil has a question. Why virtual functions happening in runtime but templates in compilation time? Well, that's a good question. That's a good line of thinking. Always trying to compare what you know with what you are learning. Templates are about preventing copying and pasting, okay? You have a general kind of, and both of them are really, that's a good question. Both of them are writing about generic code. This is a generic code, okay? This is a generic code that will work for any type of data, but it's not a compilable code, okay? To make it compilable, I need types like integers, characters, and etc. Once I get that type, okay, I can resolve all of my replacement during the compilation time. Compilers try to do almost everything during the compilation time because runtime is inefficient. When you start doing stuff at runtime, you need to waste your CPU time of your customer, which is not good, okay? With the polymorphism, I cannot do that because with the type of generic code that I am using with the polymorphism, I cannot make decision during the compile time. I have to wait until the runtime. So waiting until the runtime is not a thing that I like to do, but in the case of polymorphism, I have to, because there is no way I would know the meaning of that print function. Okay, so template's way of writing generic code is better in terms of efficiency than the polymorphism. But for the polymorphism, you cannot do anything else. You cannot make your decision during the compile time because you are writing code for the classes that you don't know yet. Remember that loop for the employees? That loop uses only the employee class and nothing else. Templates are different. In order to instantiate that swap values function, you need to know the classes. You need to know the integer or money or see. This will even work for this one. I have two money objects, M1 and M2. Okay, and I will call the swap values function on money. But to be able to compile this code, I need to include the money header. I need to know the class, okay? For the polymorphism, I didn't know the classes, right? I didn't know the classes. When I write that generic code for the employee loop, okay, or call via virtual, etc., I didn't know about the classes. That's why those decisions are done during runtime. Mustafa question, can we make function send error if one of its parameters is a string? Mustafa, what you are doing is during the compilation time. Okay? So when you say sending an error, you are saying that during the runtime, your code doesn't know that if those functions are produced by you yourself or by the template. Okay? So templates has nothing to do with the runtimes. Templates are only handled during the compilation time. If you are saying that, can I get an error message if one of the parameters is a string? Can I get a compiler error if one of them is a string? If this assignment is not doable, yeah, you will get a compiler error anyway. So if you are trying to do something like this, string str and swap values, and I am going to, let's say, do m1 comma str, you are going to get a compiler error. Where are you gonna get the compiler error? Just tell me. Line 43. When the compiler tries to compile line 43, it says that I am going to instantiate this swap values. T is going to be money, K is going to be string. Okay, line 11 is going to be fine. This auto is going to be money, right? Temp is a of type money, and this assignment is going to work. This initialization is going to work. But when I try to assign a string to a money object, this assignment is not going to work because I don't have that kind of a conversion constructor in the money class. And there is no way to convert a string to a money. So line 13 is going to produce you an error message. And this error message is going to come when you try to compile this line 43. Okay. Okay, any other questions?
Sir, can we avoid from this?
Can we avoid getting this error message, you see?
Yes.
Why would you? But that doesn't make any sense. Why are you trying to assign a string to a money object?
I mean, function won't do the swap, but sending message you cannot swap these values.
During the runtime?
It will show message. Yes.
During the runtime.
Yes.
Well, we are a compiler. We are not an interpreter. I mean, I cannot compile this code. How am I going to compile this code? If the code is compilable, maybe you can do something during the runtime. The code is not compilable. And the compiler knows this when you compile the code. Why wait until the runtime? This is not a dynamic thing. All the templates instantiations happen during the compile time, not runtime. The compiler cannot compile the swap values instantiation at line 43. And you are saying that let's wait until the runtime and give the error message at line. But I mean, whatever you do at line 43, okay, is going to produce an error message. So why would you give that error message during the runtime? It is same as saying this. I am writing a program, a main function. At the main function beginning, I did this. Okay? You are saying that don't give me a compiler error at line 19, but give me a runtime error during the execution. There is no meaning to it. This line doesn't make any sense. Okay?
Okay.
Okay, good. Any other questions? Good questions. Again, this is important. Template instantiation is done during the compilation. During the runtime, your runnable code doesn't know that if you copied and pasted these swap values function and overloaded 5 times, or those functions are overloaded by the template instantiation automatically. So your runnable code doesn't know anything about that. And to show that yourself, okay, as I said before, compile this code using -s compilation flag and see how many swap values functions are automatically produced for you. In Java, solution is a little bit different. Their solution is not exactly like templates. Some of the stuff is done during the runtime. Okay, that's what makes it a little bit inefficient and a little bit inflexible too. Okay, and we will, I think if we have time, we will talk about it when we learn about Java. Okay, let's go back to the book slides again. Let's talk more about the template theory. Okay. C++ templates again allows very general definitions for functions and classes. So far I introduced the idea of template functions, but there are template classes. The class vector that we have been using is a templated class. Okay, and it's going to come as a surprise to you, but the class string is actually a class vector, and class string are related. They are very related. There is an inheritance relationship between them. Okay, this is like a Brazilian movie. Okay, they are actually relatives. I didn't tell you this. And class string is actually a template. Class string is like a vector of characters, but it's a special one. Okay, we will see it later. Okay, so allows very general definitions for functions and classes. Okay, and the precise definition determined at runtime is says, but this is definitely wrong. I did not erase this. The book doesn't say this, but the slides say that. Okay, the precise definition determined at compile time. Okay, I didn't erase this from here because, but you asked the question anyway. Okay, I didn't erase this here because I like to point this out, but templates has nothing to do with compile times. Everything about templates in C++, all the instantiations are done during the compile time. Yes.
That's the question.
Somebody's asking a question, yeah. So
Yeah. What if we want to use the template interface? I mean, template virtual function. I mean, template abstract class, and we want to use also in a virtual function. This all at the same template time.
You are gonna see examples of it, Kamil. At the end of this chapter, we are going to modify our PFRID backup stuff. Okay. And that PFRID is going to be PFArray because we don't want to use arrays of doubles anymore, only arrays of doubles. We like to have arrays of partially filled arrays of many objects or string objects or integer objects or okay. So we are going to make them templates and ask that question when we come to that. So using templates in a hierarchy with the virtual functions is possible. Okay, for the function templates, I already talked about this, and I have this. So what do? We say that I am writing a template. When the compiler sees it, actually, it will rarely give you a error message. Okay, when the compiler says it, okay, this is a template, so I will store this at some position. I am not going to use this at all, okay, for now. But if somebody instantiates it, if somebody uses it, then I will come back to it, copy paste it, replace all those teeth with the integers or characters or whatever, and I will compile it then. Okay, so this line, when the compiler sees this line, okay, let me turn it back to the original. It's going to be T and T. Okay, if I do something like this, okay, the compiler will not give me an error message at line 11 when it compiles this line. It will give me the error message only after line 22. When it decides that I am going to instantiate that template at line 9, this line doesn't make any sense for an integer. Integer, the reference is assigned to some auto. I cannot resolve this. I don't know what that means. So that problem only happens when you try to compile line 22. Okay, when you are compiling line 22, the compiler will come to that swap values. It will try to compile line 11, and it will give you an error message for both line 11 and line 22. Okay, line 11, I am getting a compiler error. It is happening because you are trying to instantiate this at line 22. Okay, so you will not get much error messages for your templates, but when you try to instantiate them, you will get your error messages. Okay, so here this class means that you are not, of course, you are not defining a new class. Okay, but it is used as a keyword to show that I am using this class T or type T. In fact, there is a better keyword for this one. Instead of class, the better way is using type name. It's a C++ keyword again. Using type name is less confusing than using class, but I mean, it became a custom. People have been using this keyword class here, and it is accepted. So unfortunately, we will keep using this keyword class here. Instead of class, as I said, you could use type name, and type name is another C++ keyword. Okay, good. So we talked about this and function template definition. So swap values function template is actually a large collection of definitions. Compiler only generates definitions when required. Okay, so compiler only generates them when you call them during the compilation time. Again, nothing happens during the runtime. If I erase this line, okay, erase that line. If I erase this line, and if I erase rest of the stuff, all the swap values calls, okay, all of them are erased now. Okay, I don't have any swap values calls. Then between line 8 and 15 doesn't mean anything for the compiler. Okay, so even if I do stupid stuff like this, okay, or like this, stupid stuff, right? Even if I do stupid stuff like that, you will not get error messages because nobody is going to instantiate this swap values template. And if you look at your compiled code, you will not see any swap values functions. So that thing swap values template will be instantiated, okay, when it is needed. Okay. So you should not be concerned about the swap values is defined for all types of functions, for all types of data. No, it is not that way. It is not that inefficient in terms of compilation. You just write one function. Whenever it is required, it will be instantiated and it will be overloaded. Okay, so how you call a function template? Just regular function call. You make this call. Compiler sees it. Compiler first tries to find an exact match. Swap values with two integers or two integer references. Can I find it? No. There is no function like that. So can I instantiate a template? Yes. Just instantiate a template. And now I have my function. Okay. So you don't have to do anything. You are not saying compiler that instantiate this for me or anything like that. Okay. This is another template. Show stuff. And it takes this show stuff. It takes one integer and two generic types. Okay. And it will print stuff1, stuff2, and stuff3 on the screen. So how can I use this show stuff? I can use this with three integers, one integer, two characters, one integer, two money objects, one integer, two strings, etc. Of course, the stream insertion operator has to be defined for this parameter t. If the stream insertion operator is not defined for that parameter t, let's say for my, remember the pet class? Remember the pet class? If I call this pet class, if I call this show stuff with one a pet, comma, a pet, okay? When I try to compile this, I will get an error message for this one and this one. Why? Because the stream insertion operator is not defined for the pet class. It is defined for integers, but not for the pet class. Okay? So the function header, the parameter list, can be intermixed with the generic types and the concrete types. Okay, good. This will work. Show stuff. This is automatically integer. I mean, there is no way, there is no another way of doing it. And two doubles, and it will display this. It will replace t with double, and it will work. Okay, templates are nice, the idea is nice, but they are very difficult things to handle for the compilers. Compilers has to do lots of stuff. Okay, and the C++ standard 98 standard or the 11 standard says that templates will be treated like the regular functions, but some of the compilers, and that includes our G++ compiler, cannot handle some of the complications of the templates. Okay, so we will have to do some stuff that we don't like placing some executable code in our headers, but we will manage. Okay, we will manage. Okay, it turns out that it looks like I am out of my time. I started 10 minutes late, and I am letting you go 10 minutes late. Sorry for that. And if there are any questions, I can take the questions right now. Otherwise, I will see you tomorrow morning. Any questions? Okay, nobody's asking any question, and people started leaving, so they are not interested in other people's questions. So that number is going down very fast. Now it is 43. So 43 people are waiting for other people's questions. Not bad, 1/3 of the class. Okay, good. Okay, I'll see you tomorrow.